Let's talk about the mean value theorem. Just before we could get to look at the precise definition of what the mean value theorem is, and just before we get to answer the question, let's try to have a graph. Let's say this is a graph that we have, okay? And then we have an arc, that is something coming out like this. So this is our arc. And then we have a second line. Of course, we do know that a second is a line that gets to meet the curve at two different points. And then we also know of a tangent, which is like a line that cuts the curve on just a single point. Okay, so take note of that. This is the second, and then this is called the tangent. Okay, these are two different lines. So now, according to mean value theorem, the basic idea is when you do have a function, of course, that is continuous, as you can see that this curve is continuous, okay, on the given interval a and b, and of course it's also differentiable at every given point, then there should be a point where the secant is parallel to a certain tangent on a given point c. That is the basic idea. So now, what is the basic idea of the mean value theorem? So how can we write a precise definition, or how can we summarize the theorem? So if you do have a function f of x, according to the mean value theorem, first of all, the first condition here is that the function should be continuous, just like we talked about Rose's theorem. The same applies. So it should be continuous on that crossed interval. And then the second condition here is that it should be differentiable on an open interval a and b. Okay, so differentiable on that interval. And then if all these apply, the second point is that the derivative, of course this is applying to a tangent, so the derivative at a certain point c is going to be equivalent to the derivative of the secant. Of course, when you look at the secant, you're looking at 2 points on the curve or on the function where a line is cutting. So there should be a function of a and b, and then of course you should also have the 2 points b and a. So the basic idea is, on top what you're looking at is the change in y, and then on the denominator you're basically looking at the change in x, which is also giving us a gradient of the derivative. So now what we're saying is that line, which we're calling the secant, which is cutting this curve at 2 given points. So for us to find its gradient, what we are doing is we are looking at the change in y and the change in x, and this is what is being shown on the right hand side. And then of course on the left hand side, what we're showing is just the derivative at that given point, a single point c. So these should have equal gradients or equivalent derivatives, and this is basically what we are showing on the third point there. Okay, so this is what mean value theorem tells us. If these first two conditions are met, then it's possible for us to have a secant and a tangent having equivalent gradients. Okay, now let's try to see if it does apply to the question that we're given on top, and then try to see the way we're going to approach it. So what is it saying? So find the value c if a function below satisfies the mean value theorem on the given interval. So looking at the interval that we have and looking at the kind of function that we are given, this is a polynomial function. So polynomial functions, of course, the basic idea is they are continuous, unless if you get to talk about other kinds of functions like rational functions. That's why you need to be careful, because those are not usually continuous. So it should be a certain point where I would expect the function to be discontinuous. For example, let's say you're talking about let me convert this very function to something that is more rational. Let's say we can divide this function by, let's say, x, and then I try to give you Of course, if I give you that range, you can agree with me that it's also going to be continuous. But if I give you, let's say, an interval from a negative number to a positive number, you agree with me that this function is not going to be continuous. Why? One reason is because there is a zero in between there where we expect this function to be undefined. And that's one way in which you need to think about the idea of determining whether a function is continuous. Ask yourself a question: is there any point that can make a function to be undefined? Of course, we do know we can't divide by 0, for example. Okay. So that's one point that is very, very important. And of course, if you get to talk about logarithms as well, you do know that the natural log of course, by natural log I mean something ln there. If you try to find the natural log of a negative number, I think it should be undefined as well. So those are some of the functions that you may think of to be discontinuous at certain points. And of course, piecewise functions also, you need to be careful about them because they are usually discontinuous at given points. Okay, so the first condition is already met. The function is continuous. The second condition is also met. This is a polynomial function, so we expect it to be differentiable at every given point. Okay, and then since these two conditions are met, according to mean value theorem, what we do expect is, so if all these are met, then we can say the mean value theorem does apply. So if it does apply, it tells us that there should be a derivative of a tangent that is going to be equivalent to the derivative of a secant. Okay, it's very, very basic. And of course, you just need to look at the change in b as well, the change in the y and the change in the x. Why? Because the secant is cutting 2 points, and then for a tangent it's just cutting 1 point. So that's why but all in all, we are talking about the gradient at these both points. Okay, so what am I going to start with? So I'll try to focus first of all on the left hand side. So the left hand side is just requiring me to differentiate the function, and of course the derivative of this function becomes 2x minus 4. That's very basic. So I'll write that. Now it's telling me my value of x is c, so it's therefore going to be 2c minus 4 equal to, and then what do we expect to have on our right hand side? So first of all, we have the function of b, and then in this case our function of b, the good part is we are given the number. So what is our b? That is our a. So the function of b just tells us to say that we just need to look at the function and then just get to plug in the given value. So 4. So that is going to be 4 squared minus 4. So I'm just putting a 4 where there is x. And of course, what we expect, 4 squared is 16. If you subtract this, it's also going to give you minus 16 plus 3. So we just have positive 3 for our function of b. And then our function of a, so function of b, take note, is equal to 3. And then function of a, which is a function of 1. So if we substitute a 1, we have 1 squared minus 4 times 1 plus 3. So that is 1 minus 4 plus 3. And then of course, if you get to look at 1 minus 4, that's a minus 3 plus 3, giving us a 0. So f of 1 is equal to 0. And then at this point, what can we say? We found the function of b. We've also found the function of 1. So a function of b has been determined to be 3. So I'll show that. So what is a 3? So we have 3 minus f of a is 0, and then change in the x. So b minus a. So it's like 4 minus 1. Okay. And then I can erase so that we have some more space. So at this point, we'll remain with 2c minus 4 on the left. On the right, we have 3 over 3, because 4 minus 1 is also going to give us a 3. So at this point, this is equal to a 1. So we can now simplify it. So simplifying that, what we expect is 2c to be equal to 1 plus 4. And then our c is equal to 5 over 2, which you can divide to give you 2.5. So we've basically found the value of c, where we expect the mean value theorem to apply. Okay. So this is how simple the mean value theorem is. And of course, you can combine the mean value theorem. If you already know about the Rose theorem, it will be very easy for you to connect them, and it will be very easy for you to just get to connect the two, because they are all, first of all, looking at a function being continuous on the closed interval of a and b, and then being differentiable on an open interval a and b. And then for Rose theorem, the third condition holds that you do expect that there should be a point where the function is going to have a zero, a derivative of a zero. And of course, if you connect this to the mean value theorem, you expect that there should be a point. If you differentiate it, of course, it should be equal to the derivative of a second, which is just the change in y, denoted by function of b minus function of a, divided by the change in x, which is just like b minus a. So this marks the end of our video, and I just hope that now you understand what the mean value theorem is. Thank you very much for